Hello, everybody. So today, what we're going to be doing is the week 6, lecture 2, which is going to cover branching and if statements. So in the chapter 6 for this week, which maybe I'll navigate over there now. Here we go. Right. So over here in Zybooks, if we look at what we have in week 6, there's some exercises in 6.1 strings. There's no exercises in 6.2 and 6.3, but then in 6.4 and 6.5, 6.6, what we're talking about is branching. And in week 7, so next week, what you're going to see is that we're going to have more of this. But I didn't want to wait until next week to start this topic because it is an important topic. And also, this way will sort of give you exercises earlier, I guess. It'll spread the exercises out of it. So with that said, let us go ahead and get started. So I will go ahead and open this set of lecture slides. So this is called branching and if statements. Oops, Zoom stuff's in the way. All right, there we go. Let's make this bigger. Let's enlarge this a bit. And here we go. So we're talking about branching and if statements. So the whole point is to learn what branching is. And it's a very important topic in programming. Every programming language talks or has a concept of branching. Every CPU has branching built into the CPU, right? So it's a very fundamental concept in programming. And what it allows us to do is to make decisions and execute different blocks of code based on specific conditions, right? Now, what I'll show you is an example momentarily, but there's going to be a few different kinds of if statements. So I'm going to click through a couple slides and then come back. So the simplest form of an if statement, which is branching, looks like this in Java. So you're going to say if, then you have parentheses. Inside of the parentheses, you put a condition. And that condition is going to be something that's either true or false. Now, you might remember back when we were learning about types that there was a type called Boolean, and Booleans were either true or they were false. And so, what we can do with an if statement is we can make a block of code that is executed if the condition is true, but not executed if the condition is false. Now, just to demonstrate that, I'm going to come over here to Eclipse and I will just give us an example here. So I'll do system.out. Actually, I don't even think I want to right now. Before we do that, I'll do this Boolean, and I'll just say my condition, and we will make it true for right now. So I've just made this true. Actually, let's even go simpler than that. I'll comment that out. We'll just write an if statement this way. If, oops, true. Have extra parentheses. Now, when you're typing one of these if statements, what you're going to want to do is you're going to want to have curly braces that open and close after the if statement. And this is where we put our code. So this creates a code block. And the curly braces are going to separate this from the rest of the code. So anything you type between these curly braces is going to be part of this if statement, and anything afterwards will be afterwards. So if I do system.out.println and I just say, hey, this code ran, and then I'm going to, after the if statement, do system.out.println, and I'm going to say, okay, we're done. All right. So I have this code here, and if I run it, what you'll see is that we get, hey, this code ran. Okay, we're done. So both of these things were printed, right? But this top one, the one that's inside the if statement here, the reason it ran is because we had a true here. If I take away this true and I put something that's false, and then we try it again, this time it just says, okay, we're done. So this if statement here we are only going to run the code inside of these curly braces if the condition is true. If the condition is false, which it is now, then we don't run it. However, this line, line 16, which says system.out.println, okay, we're done, this is always going to run because this has nothing to do with the if statement, right? The if statement is self-contained here. So if something is true, then we run this code. Otherwise, we're doing nothing. But after this if statement runs, the rest of the program continues on and it prints out, okay, we're done. Now, the point is that inside of this if, where the condition is, you can put a lot of different things. So, for example, you can do less thans and greater thans. So, like if I say if 3 is less than 10, print it, and it prints it. Why? Because 3 is less than 10. So this is a condition here, 3 less than 10, that is either going to be true or it's going to be false. So 3 less than 10 is true. So we do get the line that says, hey, this code ran. And if I reverse that, 3 greater than 10, now it's false. So when I run this code, the line does not get printed. Does that make sense? So when we're first learning about branching, you're going to see in this, see, chapter 6, you're going to see that in 6.4, they're going to explain the concept of if and else, which we haven't talked about else yet. But the concept of if and else is demonstrated right here in this activity, which is 6.4.3, where you can see that they're using a flow chart to represent a program. And in order to see what's going to happen, you have to start at the top here and go through the arrows and execute these commands. So in this particular one, we set a variable called hotel rate equals 155, user age equals get next input. So this is somebody typing in a number for the age. So somebody's typing in their age. And then you see in a not triangle, in a diamond shape, they've got user age greater than 65. Now that's just like our 3 less than 10 or 10 or 3 greater than 10, which means that this is something that could either be true or false. And so from this diamond shape, what they're showing you is that if user age is greater than 65, so if that's true, then we go to the right here to run this line, hotel rate equals hotel rate minus 20. However, if the user age is not greater than 65, then the condition is false. So we'll come down here and we'll follow the bottom line. And so there's two options here, right? A true and a false. And we're going to do separate things depending on whether this was true or false. And that's what's going on over here too, except that we have a branch that does something if it's true. We don't have a way to do something if it's false yet. So going back to my lecture slides, which are somewhere, here they are. The next thing after an if statement, well, these are the operators. We'll come back to that. Ooh. The next thing after you know what an if statement is going to be an if else. And so an if else is similar to an if statement. It just has this extra section at the end that's labeled else. And so what this does is you'll notice that we're still using curly braces to separate out a block of code. And we still have an if statement, but now we also have a separate section called else. So what happens here is that one of these two things runs. So either the highlighted lines will run if the condition's up here, is true, or if the condition is false, then down here, we have a separate condition. So now this is like an either or. Whereas with just an if statement, like we had in our example, this is not an either or. There's only one option here. So this line, hey, this code ran, either it runs or it doesn't run. But there was no alternative, right? There were not two choices that we're choosing from. So what the else does is it allows us to have two conditions that we're choosing from. So if I were to add just an else after this, so I could just type else, open curly braces, make sure they close later, I could print something else. So like I can say here, hey, I'll just say, hey, the the first block ran. So this is the first code block. And if I copy this and I move it down here, I can say, hey, the second, I said block ran. Okay. So we have a first block of code and we have a second block of code. And which one runs depends on this statement, right? So I'll just change this back to true for now. So if I run this, it says, hey, the first block ran, right? So the condition's true, so we ran the first code block. If I change it to be false and I run it, hey, the second block ran. So one of these two is going to run, the first block or the second block, but which one runs depends on whether the condition is true or false. All right. And so that's what an if statement does, or an if else statement. And that's what is being described here, right? If statement we have just seen says if condition is true, then do thing. Often you want this pattern. If condition is true, then do thing. And if the condition is false, do other thing. And so you use an if else. And that's what's illustrated in the Xi books for that exercise. Because in the exercise, we have user age greater than 65, and we have two branches, a true branch and a false branch. We want one of them to run. Now, the false branch actually has nothing in it, so it didn't really need a false branch, but this is how it was drawn. All right. So with that said, I'm going to back up a couple of slides in my lecture slides just to give you an idea of what kind of conditions we can have. So for now, the type of conditions we can have are generally going to be these kinds. So you can check if something is less than using the less than symbol. There's also less than or equal, which we have to type this way, right? There is a math symbol for less than or equal, but it's not generally on your keyboard, right? So if you want less than or equal, you type a less than symbol and then an equal sign. Same thing for greater than. So there's a greater than, there's a greater than or equal. And then to check if things are equal, you have to use two equal signs. So this is really important. Every C-like language works this way because we already use equal sign for something, right? When we do one equal sign, it means we're setting something equal to something. And that's important because if I come back up here and like, let me just do this. Let me say like int x equals, let's just say 5, okay? Now, if I do this, x equals 5, that's true, right? So if I run it, the first block runs because this is going to check if x is equal to 5. If I change the 5 to something else, like 9, and I run it, now the second block runs because x equals 9 is false, right? X is 5. So equals is checking to see if things are equal to each other. Now, if you screw this up and you wrote x equals 9, what will happen is, in this case, we're going to get an error, which is actually lucky, by the way, that we are getting an error. In earlier programming languages, what would happen here is when you do x equals 9, it would actually just assign 9 to the x variable. And everything would run fine, except that it doesn't actually check if x is equal to 9. It just makes x equal to 9. So that would be an issue. At least here we have an error that tells us that we did something wrong and we know to fix it. What's the point? The point is if you want to check if things are equal, it's two equal signs, equals, right? Very basic programming concept. Many programming languages work this way. So you just have to understand that, right? Now, I didn't have a picture in my slides for some reason, but if you want to check if things are not equal, what you're going to see is this symbol. So an exclamation point and an equals is going to mean not equals. You'll see that in those iBooks. So now x not equals 9, that would be true because x in fact does not equal 9. And so the first block runs again. All right, so hopefully we're getting a little bit of the idea here. So we have, oops, where are my slides? Here they are. So we can check if numbers are less than or equal or greater than or equal or equals. And then we can make decisions based on that using this if statement. This is just another example. X less than Y, A greater than or equal to B, C equals D, right? So these are called relational operators, like less than, greater than, etc. There are built-in instructions on your CPU for checking things like that. Um, all right. So what we can do with this, for example, is something like this. I'm going to get rid of this stuff here, and I'm just going to write a scenario in here. So let's just say, imagine we are selling tickets. Okay. Now, what kind of tickets are they? I don't know, movie tickets maybe. So maybe a ticket costs, let's say, $15 for an adult. And we're going to define adult as being more than 12 years old. Okay. And then we're going to have a child's price for 12 and under. And that child's price is going to be, let's just say, $8. So a ticket costs $8 for um, children 12 and under, right? So that's what we have. Now, what we can do is I can make you type in an age. I can say system.out.println, type in an age, say your age, whatever. But I'll say type in an age. I'll change that to print just because that's how I like it to look. Then we need to read in an age. So I'll just say age equals, and we'll do scnr dot next int like usual. Let's run this, see what happens. So it says type in an age. I type in an age, I say 55, enter, and then our program is done. But what I want to do is calculate the ticket price. Okay. So let's calculate the ticket price. And the only real way to do this, I mean, you can actually do like ridiculous math and figure out how to do this with a formula, but it's ridiculous. The right way to do this from a programming standpoint is an if statement. So you just say if age, well, let's see. It doesn't matter which one we do first, either the adult price or the ticket or the children's price, but we pick one. So let's say we do the adults first. So a ticket costs $15 for an adult. An adult is more than 12. So more than 12 means if the age is greater than 12. Now you do have to think about this a little bit because sometimes like the right answer, depending on the wording, could be age greater than or equal to 12. Sometimes the right thing, if you read the sentences, could be greater than 12. So you have to carefully read the situation. So this says more than 12. More than 12 does not include 12, right? So you have to think about that a little bit. And we need a ticket price. I'll just say ticket price equals 15, right? Now, I need to have this variable, exist. So maybe I should come back up here and I should say int ticket price like that so that the variable exists. I don't want to try to add that here, like int ticket price equals 15, because when you're writing a branch of code like this, what you put inside the if statement may or may not run. And so you should not be defining variables in there because then it would be possible that the variable was defined, and it would also be possible that the variable was not defined, depending on what this if statement did, right? The whole point of an if statement is that sometimes we want to do something and sometimes we don't. And you don't want to be in a situation where a variable may or may not exist because then, as you must be aware by now, if a variable doesn't exist, you're going to get an error in your code, right? If you try to access it later. So don't declare variables in your if statements unless you're really sure. about what you're doing. Um, so I will declare it up here and then just use it down here. So if the age is greater than 12, the ticket price should be 15. Else, so we type else, open curly braces. When I hit enter, you might notice the way I do this. So on the previous line, I hit enter, I type else, E-L-S-E, space, open curly braces. And I open the curly braces there, and then I hit enter. And when I hit enter, it put the other curly brace, the matching curly brace to close the else statement at the end. And it put my cursor inside. That's what I want. So then I'll start typing. So it does that automatically, but it is your responsibility to make sure that every, else is going to have an opening curly brace and a closing curly brace, etc. What do we want to do here? Well, this is going to be where the children age gets words hard. This is going to be the block that runs if we're not greater than 12. So this is where the children's ticket price goes. So we'll do ticket price equals 8, like that. So if the age is bigger than 12, $15. Otherwise, so else will just mean if they're not greater than 12, then the ticket price should be 8. And after we do that, we can print it out with system.out print line, and we can just say ticket price, let's say colon equals plus, and we will put in the ticket price. So now we're going to dynamically calculate their ticket price based on the age that's typed in. So when I run this, it says type in an age. If I say 99, well, a 99-year-old person has to pay $15. If I do it again and I type in 8, well, an 8-year-old has to pay $8, right? So 5-year-old has to pay $8. A 12-year-old has to pay $8, right? Because 12 and under pays 8. So, just double check that actually works. If you were 13, you'd have to pay the adult's price of $15, right? So hopefully we see that this is just working now. Now, once we can understand this conditional statement where we have two possible things that are done, we can extend that and we can do more than two different things. So you'll see that mostly next week, but we can also see it in my slides here. So once we can handle the case of an if and an else, we can add a third thing. We can add what they call an else if in there. So what's an else if? Well, what if we have more than two possible code blocks that we need to choose from? So in this case, you can use an if, else structure, or you can use a switch statement, but a switch statement we're going to cover specifically next week, so not today. So here's what an if, else if looks like. So you have if and then a condition. And so they're numbered this time just to keep them separate in our heads. If condition 1. So if condition 1 is true, we run the first code block. If condition 1 is false, then we go down and look at the next thing. So if condition 1 is false, then we look at condition 2. So it says else space if condition 2. If condition 2 is true, then we run code block 2. And then if condition 1 is false and condition 2 is false, then we will end up doing the else. Okay. Now, what I just said out loud there is the way it works. So kind of a technical point, but an important technical point is that exactly one of these three things is going to happen, but only one of these things is going to happen. And so you have to be careful about how you write them so that you don't say something that you don't mean. Now, it's going to be a little bit difficult to explain, like I'm sort of implying that there's going to be some issues with writing these that you have to be aware of, but I haven't really spelled it out yet. So let's go over to Eclipse and let's modify what we were doing over here. So we said, imagine we're selling tickets. A ticket costs $15 for an adult more than 12 years old. A ticket costs $8 for children 12 and under. Let's add a senior discount. So let's say a ticket costs, let's just make it a different number. So let's just say $10 for seniors. And then let's just say what's a senior? Well, we'll say 60 and older. So 60 and older. Um, okay. So now we have three prices. So now that we have three prices, this is not going to cut it, right? Our two price thing. Now, what can we do here? Well, I'll show you the right way, and then I'll show you a way it can go wrong. So, kind of a tip for doing these and not screwing them up would be if you have something like this where we have three different age ranges, when you're typing up the if and the else ifs, you should put in oldest, middle, youngest. So that would be in order of age, right? Oldest and then middle and then youngest. Or in the opposite order, which would be, youngest, middle, oldest. Okay. Now, why would you want to do that? Because if you don't do that, you may, depends on the problem. So if you don't, you may run into incorrect behavior. Now, for the moment, that's all I'm going to say about it. Um, I will purposefully do it wrong in a couple minutes. Okay. So if we were going to do this, let's do it this way. Oldest, middle, youngest. Okay. So if I'm going to do oldest, middle, youngest, that means I'm going to do the seniors first. So let's do the seniors first. So if the seniors are first, let's get rid of the age there. So seniors are 60 and older. So we include 60. So that would be senior would be greater than or equal to 60. Okay. So if age greater than or 60, that's a senior. How much do they have to pay? They have to pay 10. So we put a 10 there. Okay. I'm going to delete this. So that takes care of our seniors. Now, after we do our seniors, we would need to do the adults. So that would be else if age, age. Now our adults are more than 12. So that would be age greater than 12, not greater than or equal, just greater. And ticket price should be equal to 15 for the adults, right? And then our third choice, well, if you're not greater than or equal to 60 and you're not greater than 12, then you must be a kid, right? So we just have else, and then we have ticket price equals 8. So we did this oldest to youngest is how I just organized this, right? And if we run this, we should be able to see that there are no mistakes here. This should work perfectly fine. So let me just bring this up just a touch. And let's run our code and see what happens. So we'll try people in all of the different age ranges. So let's try a 70-year-old first. So senior, ticket price 10. That's correct, right? Seniors were paying 10. Then let's try a regular adult. So let's try a 34-year-old, price 15. That's correct. Now let's try a kid. 7. Ticket price 8. That's correct. So this logic here, we just checked it and we verified it, and it works for people in all three age ranges. So everything is good here. Okay. Now, how could this go wrong? Well, what if we don't do oldest, middle, youngest? Also, youngest, middle, oldest would work. Maybe we'll do that first. So let's try the opposite order. So let's do youngest, middle, oldest. So if we wanted to do youngest, we would get the kids first. So age less than or equal to 12. That was kids. They paid 8. And then for the adults, the adults would need to be less than 60 now. If you're less than 60, you're an adult. And then the third case would be everybody else. Everybody else would be 60 and older. They should pay 10. So if I organize it this way and we try it again, so like what do you pay if you're 76? $10. That's correct. What do you pay if you were 44 years old? $15. That's correct. What do you pay if you're 5 years old? $8. That's correct. So this order also works pretty easily without thinking too hard. Now, let's do one that doesn't work. So if we tried to do this incorrectly, um, now there are, if you do avoid oldest, middle, youngest, or youngest, middle, oldest, it is possible to still get it right. It's just there's more unintentional errors if you try to do that. And it all comes down to the fact that when you have multiple statements or you have multiple conditions in an if block, the first one that's true is going to run. And so if I tried to organize this to where I did the seniors, um, to where I did the adults first. So let's say I try to do it this order. I'm going to do adults first, and then after I'm going to do seniors, and then after I'm going to do kids. Okay. Let's say I do this old order. So I got to take away, all the ages and redo them. So if you did adults, you said age greater than or equal to 12, right? That's adults. And then you do seniors and you say that's age greater than or equal to 60. And then everybody else is a kid, right? You might think that this is right. If I try a kid, 6, I get $10. Oh, actually, hold on. I didn't fix the ticket prices. So adults have a ticket price of 15, right? And seniors have a ticket price of 10, and kids have a ticket price of 8. So ignore this. Try it again. So let's do kids first. Let's say we have a 6-year-old and they pay $8. So that's good. And then you try an adult and you say 40 years old and the ticket price is 15, and that's good. So then you try a senior and you say 77 years old and it says 15 again. And that's wrong. That's wrong. And so that's where you have to really understand that what is happening here when you're writing an if else block is the first condition that's true will run. And that's the only one. So what happens is we're checking to see if the age is greater than or equal to 12. And it is, right? When you type in 77, 77 is greater than or equal to 12. So that makes the ticket price 15. Now, is 77 also greater than 60? Yes, of course. But we never are even checking this. We never check to see if they're over 60 because one of these 3 branches will run, and the only one that will run will be the first one that it's true. So when you have multiple conditions that are true, right? Age greater than or equal to 12, age greater than or equal to 60, the only one that's actually going to trigger is going to be the first one. So the order that we typed them in matters. So that's why it's a mistake to try to do the adults first. Okay. Now there is a way to do it. It's not impossible to make it work in this order. It's just a little bit trickier than what we know how to do right now. So to minimize your errors, you should probably organize them like if you have ranges of a variable like age, you should organize them from biggest to smallest or smallest to biggest. And that will minimize the chances of an error. It won't eliminate it completely, but it'll minimize it. So again, the easy fix here would be to change it so that you do seniors first and then adults. So if they're greater than or equal to 60 and then greater than or equal to 12. Of course, we have to change the ticket prices around as well. And now oldest to youngest, like age 77, we get the correct senior price of $10. We do 50. We get the correct adult price of 50. And if we pick like 9, we get $8, which is correct for a kid. So just switching it around to that order managed to fix our error without us thinking super hard about it. Okay. Now, having said that, we could have even more branches than 3. So nothing actually forces us to have only 3. So we have if and then else if and then else. You can actually, I don't know if there's going to be one in here. Scrolling. There isn't, but you could actually have multiple if else's. You can make this have like more than 3 branches. You could have 5 branches or 10 branches or whatever. And I guess we'll see that in a while, not right now. So we talked a lot about how to type this up in Java. We didn't do too much of following the flowchart, but you can follow the flowchart if you want to. Um, Here's a challenge activity. Let's just see if we can do this. It won't be that hard. I'm going to skip to number 2 here. So when we're following through this, so we just say start numcats equals 1. That's not a comparison, right? They're setting a variable numcats equals 1. The diamond shape, that's the comparison. Numcats greater than or equal to 3, true or false, right? So to do a problem like this, you would just look up and say, well, numcats is 1. So is numcats greater than 3? The answer is no, right? 1 is not greater than 3. So we follow the false branch, right? So there's false and there's true, depending on whether the condition is true or false. So numcats is greater than 3 false. So we go down. We follow the arrow and it says put D to output. They just want you to type D. Then it goes through there over here, and then we continue down and it says put K. So you type K. And that's correct. So these are not that hard to follow, I don't think. Let's do the next one. Start. Num apples is 7. Okay. Num apples less than 7. Well, this is where you have to remember the difference between less than and less than or equal. So 7 is not less than 7, right? So this is false. So it goes down. Put E to output. E. Keep following it. Put G. So G. End. Okay. So that's all you're doing there. They're not so hard, but then you have another section where they're going to, show you the what's it called? The Java for how to do this in Java, which is what we already covered. So you can see here that they're also teaching you the equals equals, which is checking if 2 variables are equal. So what do you see? This is just a regular if statement, which probably makes sense to you now. So um, somebody's going to type in a number of years married. And then if they type in 50, we're going to print congrats on 50 years. And it looks like we're going to give them a discount on their hotel rate because we're going to divide their hotel rate by 2. So we're basically 50% off if you've been married 50 years. So, hopefully that all makes sense. So if we can read a couple of these, and we'll skip to the challenge exercises in a minute. So what is the final value of num items? So bonus val is 10. Okay. Num items is 1. Then we get an if statement. If bonus val equals 10. So equals means are they equal? So in this case, they're both 10, right? 10 equals 10. So we're going to do this. Num items equals num items plus 3, which hopefully you know that that means we're adding 3 to num items. So what is the final value of num items? Well, it's going to be 1 plus 3. So 4. Yay. Next one. Bonus val is 0. Num items is 1. If bonus val equals 10, it doesn't, right? Because the bonus val is 0. So this is false. So because this is false, this entire thing does not run, right? We're not going to add 3 to num items. So what is num items at the end? Well, it starts out at 1, and then nothing happens. So it's going to stay 1. All right. This is where they teach you the not equals operator, which I already mentioned. But exclamation point equals means not equal. So if x is 3, for example, 3 equals 3, that's true. 3 equals 4, that's false. 3 not equals 3, that's false, right? Because we're checking if they're not equal. So if they are equal, it'll be false. Whereas 3 not equals 4, that's true. 3 does not equal 4. So you have to think about it a little bit, understand what it means to be equal, not equal. One little thing in here I'd like to mention, if you separate the equal signs, then you're going to have a problem in Java. So you can't separate those. So you have to type them side by side if you're going to use them that way. All right. So type the equality operator to complete the desired expression. Num dogs is 0. So that'd be checking if they're equal. Num dogs and num cats are the same. That'd be equals. Checking if they're different. Different would be not equal, right? Num dogs is either less than or greater than num cats. Well, this is kind of sneaky, right? If you're less than, you're not equal. If you're greater than, you're not equal. So if you're either less than or you're greater than, that's the same thing as checking not equal. User char is the character X equals. All right. They explain if else. We already talked about all this. So let's go down and do a challenge exercise. Um, let's do one of these and then do whatever's below this. So looking at this one, it says num puppies is 4. Cool. If num puppies equals 5. Well, what you need to do is recognize this is an if else and that one of these two things is going to run, either the top block or the bottom block. I'm not including this as a block down here. So num puppies equals 5. That is false because it's actually 4. So we are not doing the top block. We must be doing the second block. So it says system.out print line E. So we print an E, and because it's print line, we have to hit enter. And then this last system.out print line is not part of the if statement, right? Because the if statement is self-contained here. So system.out print line H is going to happen no matter what. So it's H and then enter. All right. So that's what you're doing there. And let's see if we can do, oh man, kind of long. So we might have to do more of these on Monday, but let's pick something. You can really, the nice thing about these is if you do understand the concept of an if statement, there's not really too much thinking here. You're just typing exactly what it says to do. So if I read this one, so this is 6.5.2 basic if else, and it says Write an if-else statement for the following. So that means it's going to be like this, right? If, right? And then there's something there. Going to have to close that. And then on the next line, else, then close that, right? So we know we're typing this. So you have to remember how to type it, but then let's actually look at the details. So it says, if user tickets is not equal to 7. So you just say, how do you type that? If user tickets not equal 7. Okay. Execute award points equal 10. So that goes in there. Else, okay, I already typed the else. Execute award points equal user tickets. So that goes in that block. Okay. So I really just typed exactly what this said. They wrote it in words and I wrote it in symbols. But I didn't really have to think hard. I just had to think, what is the structure of this if statement? That was, I guess, where most of the trouble was. So I'm sure we'll get this right. And we did. Let's look at the next one. Um, if num difference is equal to negative 15. So num difference is equal, so that's equals, negative 15. What do we do? Total difference equals negative 25. So I'll put that in there, semicolon. Make sure to close the curly braces. Else, so I type else, open curly braces, execute total difference equals num difference, semicolon, close the else block. So hopefully you're seeing that, like, I'm not doing a lot of thinking here. I'm just typing what it says. Okay. All right, let's jump down to these. So that they want you to know about the if else, or sorry, the else if. Um, let's find a challenge activity here to do. It says, oh, I will do this one for a particular reason. So this is 6.5.3. So there's the one like kind of word that I wanted to draw your attention here. So if integer degrees Celsius is 37. So that's just if degrees Celsius, so degrees Celsius is 37. So that's equals 37. Then what? Output. So that's we got to print something. System dot out dot print line. We're outputting average body temperature. So I'll just copy paste that in there. And the word that I wanted to draw your attention to is this word, otherwise. So if they say otherwise, what they mean is else. Okay. So when you see the word otherwise there, that means else. So that's your clue that you're on to the else part. So it says output, not the average body temperature. So I'll copy my previous statement there and I will just replace the text with not the average body temperature. That, and don't forget to close your else. So be careful how you type these so you can match up the curly braces and so on. And we should be good here. And we are. I'll skip number 2 and go to number 3. Ah, so if integer num players is 3, do something, 4, do something, 5, do something, otherwise. So this has a bunch of different things to do, right? And that's what I told you about how when we're doing this scrolling up to here. When you have an if and an else if, you could actually have as many of these else ifs as you want. So you can have a bunch of different um, statements there. So what we're doing here is we have like actually four possibilities. So we have trio, quartet, quintet, and otherwise. So there's actually four different things there. So if I'm typing this, I have to do an if statement, I know, and it's based on, it says integer num players. So if num players is three, that's the first one. So that's if num players, and it's equal, so that's equals three. Then what do we do? Then we're supposed to output trio. So you have to do system dot out dot print line trio like that. And then you have to do quartet and quintet similar way. So you have to do an else if and then a condition. Well, the condition's pretty much the same as we have up here, right? Except that instead of num players equals three, it's num players equals four. And then in that case, we print out quartet. Close that. Well, then you have to do the same thing for five, right? So there's a lot of repeated code. So I can actually just copy this entire else if thing, hit enter, and put another one down there and change just the number to five. And I guess this is quintet. Is that right? I don't know. So we did trio, quartet, quintet, and then otherwise. And again, otherwise means else. So else. And then we have to print something out. I'll put it there. And it's another number of musicians. So I'll replace it there. Okay. So hopefully you can understand this, right? So if it's three, we print trio. If it's four, we print quartet. If it's five, we print quintet. And for anything else, we do the else. And that's what otherwise means, is the else. Okay. So that's kind of the real basics of if statements. Next week will be a bit harder, or not harder, but there'll just be a lot more of this. So um, hopefully, hopefully you can do this week and get a little bit of grounding in it so that next week is a little bit easier. I'm gonna go ahead and stop here and talk to you guys later.